Hi, welcome back. We're going to do another half-life section today. We are going to now be looking at half-life of radioactive isotopes. So right now I'm going to switch myself into my tablet mode on my handy dandy laptop. And I'm going to, I do want to do that. And I'm going to be able to take some notes. Alrighty, so let's pick what color are we going to be using today? I'm feeling very radioactive. Would be a good one for orange. Okay. So, half-life of radioactive isotopes. Important thing to know is that you need to be able to look at reference table N. Okay, so reference table N. So let's go over to our reference tables, right? So reference table N is going to be right here. Okay, and so here on reference table N, we have listed the half-life, right? So we've got, oops, I'm just messing around with the computer, trying to highlight here for you guys, and it's just not wanting to do what I want it to do. Is that working? No, and no. Apparently I'm not going to figure out the half-life. There we go. I'll just circle it that way. Okay, so the half-life. If you are not given a half-life in the question, you need to find the half-life here on table N. So here you have a whole bunch of different nuclides, right? And careful, you got to be a really good reader because if we look over here, there's two, I'll just use a little bit of yellow here. There's two, I'm not really working this well today, two potassiums, okay? So, and then there's also a couple of other elements that there's more of. So make sure you know which isotope that you are going to be working with. All right, so back to our nuclear worksheet, and let's just see if, my pen's working. And let's get started on the first question. So the first thing I like to do is I like to set up a table. So this worksheet doesn't give me that much room. So I'm going to do my table sideways. So here we go. And I'm going to do a table like this. Okay, so, and I'm going to do time, and I'm going to do mass or amount. So first step, set up a table, right? Time and amount. Second step, we have to figure out where does time start? Well, every time a race starts, no matter what kind of race you're doing, time always starts at 0. If you don't start at time 0, you're going to get the question wrong. Time does not begin at the half-life. When the half-life is 26 minutes, for example, that means that in 26 minutes, you've already have half of your sample has been converted. So we are starting at time 0 with a whole amount. Second, now we're on our third step. With our third step, we want to make sure that we're putting in all the information that we're given in the question. So we have a 100-gram sample. So at time 0, we have a 100-gram sample, right? Just filling in the information that I know. And I have gold 198, right? This is the element that I'm looking at, is left. I want to know how much is left after 8.10 days. So then my end time is 8.1 days. And its half-life is 2.70 days. So that means that every 2.7 days, that 100 grams gets cut in half. So then at time 2.70, so at time 2.7, we now have 50 grams. So then another 2.7, right? So if I do 2.7 plus 2.7, right, that will be a 5.4, right? You're going to have a calculator right handy dandy with you when you're doing these problems, right? So then that 50 grams now becomes 25 grams. So then that 5.4, we're going to add another 2.7, right? So another 2.7 years. So then that's going to be where our 5.4 actually goes to 8.1, right? So 5.4 plus 2.7, right? That's going to be our 8.1 years. So then that 25 grams, 25 divided by 2 is 12 and a half. So I met my end time. This is the amount that is remaining of that gold 198. So then that's going to be 12.5, don't forget your units, grams. All right, let's move on to the second question. So in that question, they give you the half-life. If they don't give you the half-life, you need to go to the reference table N, or you may be having to figure out the half-life. Okay, setting up a chart. Step 1, right? Time and amount, right? Or mass. Time 0. Now I'm going to go into the question. I'm going to fill in the information that I have from the question. I have a 50-gram sample of nitrogen 16 and it decays to, so this is how much I end with, 12.5 grams, and this in 14.4 seconds. So this is how long that takes. What is the half-life? So now I'm solving for the half-life. I'm not solving for how much is left. So I know that I'm starting off with a 50-gram sample. So how are we going to go about doing this? So I know that this column, this first column here is where I start. Then I'm going to finish at the end. So I know at the end I have 12.5 grams. Sorry for yucky, ugly decimal point. And then that takes, oops, I flipped that. I've got to put that on the bottom. Okay, so then my end amount, is 12.5 grams. My end time is 14.4 seconds. So now I just have to figure out, well, how many half-lives went by to go from 0 to 14.4 seconds or 50 to 12.5. Well, I know that every half-life, right, our sample size gets cut in half. So 50 is going to become 25. 25 is going to become 12.5. And then 12.5, oh, that's where I end, 12.5. So then that takes 14.4 seconds, right? I'm just going to cross those out because I don't really need them. I just gave myself too much space. So now I just have to figure out how many half-lives was that. Well, I went 1 hop and 2 hops. 2 hops. So then I'm going to take that 14.4 and I'm going to divide that by 2 half-lives. And then that's going to be a half-life. So then that's going to be 7.2, and then that's going to be seconds. Easy peasy? Okay. All right, let's move on to the next one. Okay, so here we have our chart. I'm just going to do T for time, M for mass for short. And time always starts at 0. Then we're going to take what we have in the question. We're going to fill in the chart what we have to start with. So the half-life of potassium-42 is 12.4 hours. So I know that after 1 half-life, oh, my messy handwriting today, kids. All right, my messy handwriting is going to say that my first half-life is 12.4 hours. How much of a 750-gram sample, so my good reading skills tells me that this is how much I have to start, is left after, this is how much my end time. So I'm starting with 750, and my end time is going to be 62 hours. Okay, so 62 hours. So then I started off with 750. 1 half-life gives me to 12.4. So 750 becomes 375. All right, so then 375, right, that gets cut in half again. That becomes 187.5, right? And then another 12.4, right? So add 12.4, 12.4, then you're going to get 24.8, right? Are we at our end time yet? No, our end time is 62. Keep on going. 187 cut in half is 93.75. So 93.75. All right, and then another half-life. So add 12.4 to that 24.8, and that's going to be 37.2. Oh, am I at my end time yet? Nope, my end time is 62. Got to keep on going. So that 93.75 is going to be now cut down to 46.875, right? And then that is now going to be, I'm going to erase my 62. I'm just going to move it over here. This is why we do math in pencil. All right, so then 46.875. Actually, I'm just going to move that over even further. So just let me write down the 46.875. So then this is going to be 49.6, right? So 37.2 plus 12.4 is going to get us to 49.6. Are we at our end time of 62 hours? Nope, got to give myself a little bit more time. 46.875 cut in half. So that's going to be 23.43. And then 49.6 plus that 12.4 half-life, right? Time keeps getting added on. And there is our end, right? After 62 hours, there is only 23.43 grams remaining. All right, let's move on to the second question. The fourth question. Okay, so question number 4. Again, we want to know what the half-life is. So this is very similar to question number 2. So then I'm going to start by making my chart, and I'm going to do, oh, come on, chart. I'm going to start my chart, and I'm going to do time and mass. Time always starts at 0. Now I'm going to fill in the information from the question. What is the half-life? Okay, that's what I don't know. 500 gram sample. So there's my start. Right? I'm starting with 500 grams. And it decays to 62.5. So it's going to decay, and I'm just going to write that on down over here. So 62.5. And it takes, right, these are my ending amounts, right? My 62.5. And that's going to take 6,000. And then, 639,000 years. It's a really long time. Okay, so now what are we going to do, right? Just like question number 2, we're going to figure out how many half-lives go by, right? Because we have to get from 500 to 62.5. So 500, cut that in half, 250. Okay, that's one half-life. 250, cut that in half, that's 125. Right, so one half-life, 2 half-lives. Am I at 62.5? Nope. So I'm just going to keep on going. 125 divided by 2. Now that gets me to that 62.5. So I went 1, 2, 3 half-lives. 3 half-lives took 639,000 years. So then I'm going to take 639,000 years, and I'm going to divide that by 3. And that means that each half-life is then 213,000 years. Make sense? Okay, just like question number 2. All right, let's go to our last 2 questions. Okay, so here we have something in scientific notation. You should be able to do this in your calculator. No worries. I have faith in you. We're going to go and we're going to do our time and we're going to do our mass. Time always starts at 0. Okay, step 1. Step 2, get the information from the question, put it in its place in the chart. So the half-life, right, is 1.4, and then I'm just going to do that down here, times 10 to the 10 years. Oh, bad little 10 there. Not to the 110 years. Oopsie. So remember, I'm drawing with my finger on this tablet. It's kind of not as easy as you might think. So 10. Okay. If there are 25 grams of the sample, right, 25 grams of the sample left, okay, so that means my end is going to be 25 grams, right? So my end is going to be 25 grams. Okay. And the end time is 2.8, and then times 10 to the 10 years. Oh, there I go with that 10 again. Okay. How many grams were the original sample? So what this is I do not know the starting amount. But what I do know is that I would divide by 2 to go from here to here. So if I divide by 2 to go from there to there, if I'm going to go in the reverse, I'm just going to multiply by 2. Does that make sense? All right, so let me just erase those lines so I can write in there. Okay. All right. So 25, right? Multiply by 2. What does that give me? That's going to give me 50. Good job. All right, 50 multiplied by 2. That's going to give me what? That's going to give me 100. All right, so I got that part. So now I got to do the half-life part and to see how this all fits in. So 1.4, right, times 0. So then at 1.4, and then I have from 1.4 to 2.8 is how many half-lives is that? So then that's one half-life, and that's my two half-lives. So two half-lives. That's why I did just 1 to 2, right? Two half-lives go by. So my original amount, 100 grams. Okay, so just working backwards. Okay, let me just erase this so I have some more space. Okay, so there are, remember, we're going to do our chart, our time versus mass. Okay, so there's 5 grams of iodine left, 31 left after. So I have 5 grams, and I have that's left over 40.35 days. How many grams are in the original sample? Okay, if it's half-life, right? The original sample at time 0. If it's half-life, it's 8.07 days. Okay, so just like question number 5, I'm just going to work just a little bit. Instead of working from the top, I'm going to work the bottom column down first. So 0 to 8.07 is one half-life. Do we agree? Right? Because that's what the half-life is. So if I add another 8.07, that's going to be 16.14. All right, am I at 40.35 yet? No. So I'm going to add another 8.07, and that's going to be 24.21. So 24.21. Am I at 40.35? Nope. So then I'm going to add another 8.07, and that's going to bring me to 32.28. So 32.28. Am I at my half-life of my end time of 40.35 yet? Nope. I'm going to add one more 8.07, and that's going to bring me to 40.35. Okay, got that. Now I got to figure out how many times I'm going to go backwards. So then I go one half-life here. So that's 1, that's 2, that is 3, that is 4, that is 5 half-lives. Correct? All right, now we're going to work ourselves backwards. So we're going to take this 5 and we're going to multiply by 2 across those 5 half-lives, those 5 hops. So then that 5 becomes 10. The 10 becomes 20. The 20 becomes 40. The 40 becomes 80. And then the 80 becomes 160. Oops. And there's our starting amount, 160 grams. Okay, so you have done, for the most part, all of the types of half-life questions that you would possibly be asked on a test or the Regents. The only one that you have not seen on this page is determining fraction remaining. And so just if you're, doing like 100 divided by 2, divided by 2, divided by 2, we can do the same thing with fractions. The clue is at time 0, in that case, you're starting with a whole. Then a whole becomes a half, and a half becomes a fourth, and then a fourth becomes an eighth, and an eighth becomes 1 over 32, and then 1 over 64, and we could go on. Okay, so that is half-life. My advice to you would be to write these problems down on a separate sheet of paper if you're struggling. If you got this, and you could do all of these problems, that's great. But if you're still having a little bit of trouble with this, write these problems down on a separate sheet of paper, redo these problems, go back and check the answers, go back to the video and watch the process. And then if you're still having trouble, right, you send Mrs. Mitiga or myself an email or a little post on the Google Classroom, and we can provide you some further clarification. All right, thanks for listening. Until next time, bye.